I'm John Furter, Director of Engineering for Multi-Line Video and Fiber Optic Systems and SMPTE Secretary Treasurer. So this morning's session explores new techniques in monitoring, transmission schemes, and piracy prevention to provide consistent, safe, and secure content delivery to the growing number of over-the-top subscribers. Our first presentation is from Jeff Herzog, entitled Broadcast and OTT Monitoring, the Challenge of Multiple Platforms. Jeff is Principal Product Manager for Volcan Media Intelligence with Verizon Digital Media Services. He has over 15 years experience in digital media, broadcast, and post-production. Jeff supports Volcan's existing broadcast compliance and monitoring customer base while integrating Volcan Media Intelligence into the full suite of VDMS services. Jeff holds a Bachelor of Arts degree from Williams College. Please welcome Jeff to the podium.
Thanks.
Thank you.
Good morning, everybody. So I want to start off and set the context of this talk with a little audience poll. So we all watch some amount of TV, probably some via traditional broadcast, some via over-the-top, via video streaming. So just take a poll. How many of you can remember the last time when you were watching traditional television via, over-the-air or cable broadcast, satellite perhaps, where there was a technical impairment that you noticed? So raise your hand. How many actually you got, keep your hands up if you got so frustrated with that impairment or it lasted long enough that you actually abandoned the service or the channel you were watching? So a couple hands. Now, how many of you watching an OTT service can remember the last time you had a technical problem watching an OTT service? Like double, triple hands, and keep your hands up if that actually caused you to abandon watching the service. Almost all of the hands stayed up on that last question. So that really sets the stage for, what we're going to talk about today. And that gap, that difference between traditional and OTT is really borne out by the numbers, by the research numbers. So 86% of viewers say that it's very important or extremely important for them to get a TV-like quality experience every time they watch and on every screen they use. The technical difficulties involved in delivering an OTT stream, the end user doesn't care about. They think they're equivalent and should give the viewer, give them an equivalent quality level. What are the top reasons they and you all abandon an OTT stream? Video buffering, poor quality video, lack of device support. I'm on an Android, I'm on an iOS, whatever stream isn't available. Or it takes a long time to load. And when viewers have these problems, the average viewing session falls by 77% when there's a significant impairment of the video quality. For instance, if they have the second or third buffering delay or it doesn't load within 5 or 10 seconds. So this is a huge issue, and this is a huge and growing market. The OTT video market is increasing at 10% a year to grow to almost 50 billion in 2022. And by 2020, video is going to be over 80% of consumer traffic on the internet. And users are watching more video, but not more TV, because it's all online on streaming platforms. So huge market, big problem. In fact, if you run the numbers, according to a Frost & Sullivan report, you sort of gang up the aggregate numbers based on what we know, 10% of viewers are going to abandon an OTT service because of a poor streaming experience. And at that 10% churn, direct-to-consumer OTT providers are going to lose 130 million, but only spend 17 million to prevent the loss. Those were 2017 numbers. By 2023, they project that those OTT providers, churn due to, for instance, canceling an OTT, subscription service, et cetera. Those providers will lose almost $500 million, but still only spend $27 million on preventive monitoring. So it's really a huge gap as well as a huge opportunity here in the marketplace. It's really the Wild West when it comes to OTT monitoring. So what's the challenge, and what's in monitoring? What are the big challenges? One is that the quality of service delivery from CDNs and video providers is really a black box to content providers who are delivering content over OTT. They think it works pretty well, but they don't really know. It's also lack of root cause analysis troubleshooting capabilities. So you might know that you have a problem, but you don't know where in a very complex delivery chain that problem is manifesting from. And as we saw, problems have a significant and immediate impact on viewer experience, and consumers have a lot of choice, and so technical difficulties have a severe impact on revenue and monetization on OTT. So therefore, the goals of an OTT monitoring system to address this are that it's cost-effective and scalable, gives you detailed visibility and tracking into delivery performance and quality, and that you implement as many coverage points for monitoring as possible through the distribution chain. And we'll talk about some of these options during the presentation. And you really want to monitor at pre-origination, where the signal is originating within the broadcast facility or content provider, all the way out to the network edge and even to the end user players themselves to get an accurate view of your user's experience. So what are the types of things that OTT providers care about? KPIs for OTT delivery, key performance indicators. One is QoE, quality of experience. So these are metrics like, what is the customer's experience on the end device as they're viewing the content? Static screen, black screen, missing content slates, technical difficulty slates. MOS scoring is one option to also judge the relative quality of it's called a mean opinion score. So you can, basically what is the viewer's perceptual video quality view of a particular content, and there's a lot of research into that as well. On the quality of service level, you want to be able to monitor the quality of CDN delivery and performance. So metrics like latency, throughput. What is the quality of the pipes that are delivering the content? Providers obviously care about ad monetization because this is all being driven by eyeballs, right? You need to be able to effectively deliver ad impressions to your end viewers. From a legal perspective, closed caption compliance is incredibly important, starting to get more teeth in the OTT world around, have it in the broadcast world a long time, rules around closed caption compliance, and that's starting to get a lot more teeth in the OTT world as well. How quickly does a video load? Or what are the rebuffering metrics? How much is the player rebuffering to seek back to video? And then can you maintain the quality and performance at massive concurrent connection scales? Can you scale out and maintain quality when you're streaming the World Series, the Super Bowl, et cetera? And then finally, is DRM and security maintained throughout the process? So we're not going to touch on all of these, but we'll touch on the way current monitoring solutions out there in the industry, some of which we're building within VDMS, address some of these issues. So where can things go wrong? It's a very complex process, and I'm going to gloss over it today. But basically, for an OTT service, you have a live source stream originating somewhere. Could be a stadium, could be a broadcast control playout facility. Wherever it is, you have, say, a live linear stream or a live event stream originating somewhere. That then has to go into live content encoders, which actually make the OTT streams. There's a pretty complicated process by which, and we're going to go into this a little more in depth, by which the video is segmented out. Once it becomes H.264 at a mezzanine level, it gets chunked into, say, 4-second chunks. And then we make a lot of renditions or profiles to be able to deliver content. And we'll talk about that to different end devices with different playback capabilities or bandwidth levels. Then all those chunks get replicated out to an origin server within a CDN and distributed out to the CDN endpoints and on to viewer client devices. So each one of these letters, each one of these points is a potential monitoring location. Today we're going to focus a little bit on point A, monitoring the input contribution feeds to the OTT delivery pipeline, as well as the end of the chain towards the end user devices. So at the first stage, this is the broadcast origination stage. This is before we're encoding the OTT renditions and segmenting and packaging. So the concept here is garbage in, garbage out. If you don't have a good input signal, then it doesn't matter what happens downstream, you're not going to get a good result, and your end user performance will suffer. And you need visibility if you're an OTT provider getting contribution feeds from third-party sources. You need to know that the streams that are coming into your environment are good and solid and stable. So what do you want to do at this level? So one thing you can do is basic quality of experience metrics. Black screen, static screen, audio levels. Is the signal coming in good and stable, not having any of those QoE type metrics. If it's a transport stream, you can actually do TR-101-290 analysis. So we'll talk about this in a minute as well. So this basically defines how a correctly formatted transport stream will behave according to a number of different error conditions or priority levels that could be anywhere from a minor impairment to potentially taking you off the air. And I think the next presentation as well is going to dive a little deeper into that. We also, very useful to do metadata monitoring and alerting. So you want to alert on, the presence of closed caption in the incoming feed. Also very important are SCTE 35 or 104 triggers. So these are metadata packets within the video transport stream or SDI signal that actually in the traditional broadcast world would signal downstream playout event to insert an ad. In the OTT world, they are also used to insert and go into ad pods or ad breaks in the OTT world. So for monetization, it's very important that those triggers get into the system and the pipeline downstream. And it can be useful to record an affidavit here as well. So this is an example of a dashboard, a Volleycon transport stream monitoring dashboard. There are many out there in the industry. This was originally built for the traditional broadcast industry, but because mezzanine transport streams are often the beginning of the OTT feed, it's very useful to apply this same technology to monitor the transport stream. So it gives you an accurate picture into the quality of the signal at different, as far as different error levels. This is what the SCTE 35 and 104 monitoring looks like. It actually gives you visibility into the payload and the delivery of those SCTE triggers referenced against the video, so you can actually make sure that your timing going into ad breaks is correct. So that's a very quick, simplified view of some of the things you want to do on the ingest to make sure you have a stable signal coming into the pipeline. Now we're going to focus on the end of the chain, so getting at point E as close to, monitoring points as close to the edge or the end user devices as possible. And we're going to talk about a number of approaches and challenges there at that monitoring point. So to do that, we need to have a little bit of a digression into a basic primer on HLS, adaptive bitrate delivery. So most OTT is delivered today by HLS. Dash is becoming prevalent as well. HLS and these other related protocols use adaptive bitrate streaming. So what does that mean? Again, that incoming single mezzanine bitrate file is transcoded into multiple resolutions and bitrates, which are targeted either for the capabilities of different devices. Your 4K TV might have a 4K rendition or profile it's playing, whereas your iPhone on barely a 3 or 4G connection or older device even may have a much lower connection. So it would get a lesser rendition. And the protocol actually allows you to change, to switch renditions on the fly. So because the video is segmented, the player has a complex algorithm where it can basically pick a middle rendition to start and either scale up to a higher rendition or down to a lower rendition if it's running out of buffer to produce the best user experience for the viewer at that particular condition combination of bandwidth and player capabilities. So the challenge is, how do you monitor this payload of multiple renditions? There's a couple approaches to get an accurate picture into the quality of delivery post-CDN of this HLS delivery. So one approach out there in the industry today uses what I would call passive end user device monitoring, where API is embedded into the player, and there's a beacon and code that basically monitors the buffering via very granular view into the actual end user experience. So how much are the actual players on millions of end user devices experiencing the stream? How are they doing? Are they falling behind? Are they rebuffering, et cetera? This is great because you can actually be assured of the viewer experience that your end users are getting. And some examples of this type of monitoring service are Conviva or Nice People at Work. And this can be very valuable, but the con to that type of monitoring is it doesn't give you any visibility into a certain sort of class of errors, QoE faults, black screen. It doesn't give you root cause analysis. It tells you that there is a problem with a particular type of device or geography of your end user viewing population, but it might not tell you why. And it might not alert you if there are any other problems in the feed, like closed captioning faults or black screen or static screen. The other approach is active or synthetic monitoring, where you're consuming a feed directly from a probe acting as a player. And that's really what we've been focusing on our product development in Verizon as far as monitoring options. And we're going to discuss two approaches and the evolution that we've had in building products to support this need. So one approach is actually a full download and decode of a single HLS rendition. So you pick a middle rendition, say a 1.5 megabit array, and via on-premise or cloud-based probes, you can actually consume the full video payload and decode and store the video. Just like basically a big DVR on steroids with all the technical metadata, including the closed captioning. And that essentially lets you check the quality of experience and the content availability through the entire chain. And you can start to get some sense of whether you have a worldwide or geographic specific problem if you do this in multiple regions, either on-prem or on cloud. And it can be useful to have an affidavit recording, again, to potentially show upstream providers that there's a problem. Kind of call this the canary in the coal mine approach. It's very useful, but it also has its limitations. This is what a user interface that we built looks like. Just to bring it back to reality here a little bit, the VDMS NOC is actually using this tool set to monitor some of our own key streams and take action if we have any QoE or missing content slate issues. So just to give you an example, these are all QoE faults that have been opened over time on various feeds. So you might have our recording going along well of an OTT feed. We're actually at an ad break right now, and mid-ad break, all of a sudden we pop over to a missing content slate. Well, obviously this is a problem for monetization. Eventually this will come back, but the NOC will then pick up the phone and use this alert to start to do deeper root cause analysis into the fault. Eventually this will come back to the missing content, or back to the content, and it'll go along its way, but that's something we wanted to investigate, right? So now you have a recording and an affidavit and a fault opened that can then be actioned. It actually gets dumped into a Slack alert and into a ServiceNow instance so that they can start tracking every instance of a missing content slate. And these recordings, when you combine the pre-ingest broadcast contribution feed with the downstream sort of post-CDN affidavit record, you can start to visualize this on a multi-viewer and see the path that your video is taking throughout the workflow on a NOC or a desktop multi-viewer type wall. So that can be very useful as well. What are the drawbacks of this approach? It's limited root cause troubleshooting visibility. As I said, it's kind of the canary in the coal mine. You know the canary died, but you don't necessarily know why or where the source of the problem is. Also, we started, the math on full rendition coverage we started to calculate becomes very difficult with a full record, especially if you're using public cloud AWS. The total download payload of a typical adaptive bitrate feed could be over 50 megabits per second. As we're moving into 4K, it could be much greater because you have your, say 12 megabit 4K array and your 6 megabit 1080p array and your 4 megabit 720p array. If you're going to monitor all those, it starts to add up to significant bandwidth, disk, and CPU. So there's, that can be a concern as well. There's also, we have various approaches for penalty boxes and such, but if you're monitoring at scale with hundreds of OTT services monitored across multiple regions, that can mean a pretty significant need for human eyes on glass in a monitoring facility, even with the best, penalty box and multi-viewer type displays. So we're trying to avoid that. So we realized we needed a new approach to OTT monitoring post-CDN, something that was much lighter weight. So we started to build a new service that could inspect, report, and alert on the manifest and playlist performance. And we're going to talk about that in a minute and do a little deeper dive into that and the adherence to that spec, the HLS spec. And check actually just that all the video chunks in all the renditions are actually available on an HTTP level, as well as check QoE on all renditions and many other KPIs on the HLS and CDN delivery quality. The key points in this tool set were to avoid downloading and decoding and or storing the full video payload, except perhaps on exception. We also wanted to be able to check all the renditions because you don't, again, know which a viewer is going to be consuming at any given time. We also wanted, to be able to check both QoE and QoS metrics. So the typical metrics around, what are there any actual faults in delivering the content through the pipeline, but then on out to the CDN and the quality of your CDN distribution, which again, as I said, is a pretty opaque black box. And we wanted it to be easy and cost-effective to deploy widely on the edge near viewers. And part of this was that intermittent checking would be an option. So instead of a live 24/7, 30 frame per second check, you might actually check less important OTT services every couple of minutes. So I mentioned the manifest and playlist a minute ago, so let's take a little bit of deep dive into that. The manifest and playlist is the only mechanism for the player to know where to find the first and the next video chunks to play in an HLS stream. So these are text files that are generated by the HLS origin server. In many cases, these are actually generated dynamically for each new user because they're potentially, adding ads, user-specific advertising into the stream. Those new manifest files represent a snapshot in time, depending on the OTT provider, anywhere from 30 seconds to 5 minutes. And they need to be delivered promptly and continuously to the player before the player runs out of buffer. And they may take a different path to the end user than the actual video chunks. They may or may not go through the CDN. So it's very important, to be monitoring these. This is what one looks like. Just to do a little bit of a deeper dive in it, to zoom in on the blue section, which is one stanza. This basically tells the player what are all the renditions and where to find them. Things like, what's their bandwidth, what's the codec, what's the frame rate. So those are all things that have to adhere to the HLS spec. And we can actually, as part of our tests, bake that into the KPIs that we're checking and warn you. Things like, the bandwidth of this particular rendition said it was 8 megabit, but you're only delivering 4 megabit video via the CDN. Those type of checks. As well as follow all the links. The last line there is a link to the actual rendition playlist, and then the rendition playlist has the links on down, the HTTP links down onto the actual video chunks themselves. So sort of logically, what does this look like? We're following this hierarchical tree of HLS down to the actual video payload. So the top level is the master playlist. The master playlist refers to all the rendition playlists, 1 megabit, 5 megabit, 10 megabit playlists, different resolutions. And then each rendition playlist refers to the actual video segments or chunks, which are made up of, say, 4 seconds each, again, depending on the provider. So what we're actually doing in this lightweight checking is we follow this tree down, and we're actually download the first keyframe, enough of the content to download and decode the first keyframe of every video segment. So we avoid the heavyweight lift of having to download the entire video payload, potentially. although there may be instances where you still want to do this. So what does this look like from a UI perspective? Of course, you want all these tool sets to be available via API to integrate with other alerting mechanisms in-house, Splunk, et cetera. But it's also handy to be able to have a UI to visualize this, all these checks and potential failures in one concise display. So each one of these tiles is an actual OTT service that we're monitoring. You can see we're monitoring each of these services in potentially 2 locations. We are able to distribute a series of lightweight geo-distributed probes to actually consume these feeds from multiple locations. And then you see that each of them has a certain number of renditions as well. And when you're looking at the UI, each of these will update every time we run a check and grab a new playlist. So you can actually go into the detail of one check. So this gives you a tremendous amount of information. Each row here is a particular rendition, and each new thumbnail is the first keyframe of a segment. And can zoom in on the top area. That shows you the results of all the KPIs, all the checks we performed on that last check. So everything from the master playlist level, how quickly did we download the master playlist? Were we able to then follow the links out to the rendition playlists? And then down onto the QoE level, were there any static screen or black screen? If you get 3 of the same frame in a row, you can deduce that there's probably a static screen on that rendition. And at every point where we've run trials and POCs with customers, we've found interesting things with the quality of delivery through their providers that in many cases they didn't know. In this case, one of the important checks we run is are all the renditions time aligned? So if you're switching bandwidth, if you're going from your Wi-Fi to a questionable cellular connection, you might downgrade your connection. Well, if you downgrade your connection and the renditions aren't frame aligned, then you cause a jump or stutter in the content because of that misalignment in time. So this tool set can help you visualize that. And then you also get a huge amount of troubleshooting and performance metrics over time. So the system alerts you in real time if you have a real issue you need to action now, but it also gives you a sense of what has been the quality of delivery over time. Have you been trending on certain types of errors, HTTP errors, static screen, et cetera? So each one of these blocks is actually a check in time. So there's a tremendous amount of value in storing all that information over time. So that was just a brief view into some of the tool sets and the way we think about OTT monitoring and the pros and cons of each of those. In summary, I would say OTT providers should invest in as much diverse monitoring technology and in as many points of the chain as they can afford. You really want to get a holistic view on the quality of delivery. And that needs to begin with the broadcast origination monitoring and then extend out to the end user as close to the end user as possible, as well as with as many points in between as you can manage as well. On the post-CDN side, there's multiple complementary approaches, and each have trade-offs. And as this evolves, we've got to evolve the monitoring technology along with it. Thank you.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.